Hi everybody, I'm Professor Kendra Erk from the School of Materials Engineering, and today I'm going to talk to you about what MSE students do and where they go. So a little bit about me first. I was born and raised in Ohio, and I'm actually a Purdue alumni. I graduated in 2006. I did tons of fun stuff when I was an undergrad. I was involved in the Women in Engineering program. I did undergrad research, learned how to metalsmith. After Purdue, I went on to graduate school at Northwestern University. Then I was a scientist at a national research lab outside of Washington, D.C. And then I came back to Purdue in 2012 and joined the department. And so my role within MSE is I teach undergraduate courses. I lead a research group on soft material mechanics, and I'm also the chair of the safety committee. On the side, I'm married and I have 2 young kids as well. So it was my dream job to come back at Purdue, and I'm thrilled to tell you about what Purdue MSE is. So the big thing is that we make stuff that things are made of. And so we design new materials that enable new designs, and we also modify and improve existing materials. We like to analyze why materials work well or when they fail. We develop processing methods in order to reduce energy use in terms of sustainability. We work in multidisciplinary teams, and we do tons of hands-on stuff and some computational work as well. So what MSE is and isn't. So it's a very broad discipline, and so we really work between atoms to aircraft. So we start at the very small nanoscale, but we go all the way up to the macro scale. So one thing that MSE isn't is we don't do a lot of chemical reaction engineering to design high yields. That would be chemical engineering. We also don't really focus on the shape of the airplane. With new composites, that would be more like industrial design and aeronautical engineering. But what we do actually take part in is designing the composite materials that are used in new airplanes. We test those new composites, and we make brand new composite formulations that have never been tried before. So for instance, with our new airplanes, the majority of those components are composites. Everything gray in that image there is a composite material. And that's what MSE is. Those are the materials that we design and work with. So we do all sorts of things in our career because it's a very broad major that's a combination of both science and engineering. So most of us make stuff that the other engineering majors use in order to make different components for different applications. We work on production efficiency. We're also very cognizant of environmental issues. We always want to lessen our impact that we have towards the environment. We do a lot of work on teams, specifically multidisciplinary teams, where we're working with all different fields from science and engineering. A lot of us also go into government agencies, national labs. Some of us teach, like myself. And there's a whole side of the field that focuses exclusively on failure analysis and material testing and validation, quality control. So where do we work? Well, everywhere. Our skills and knowledge are highly relevant to every field of engineering. And all of these bullet points on the screens are examples not only of the different majors, but ongoing research within our MSE department as well. And so you can see we're kind of the glue that pulls together all of science and engineering. And we work in all different sectors, from making paper to making airplanes to even making pharmaceuticals and new shampoo. So my work at Purdue is actually focused on soft material systems. So historically, materials engineers came out of the metallurgy field, but now in Purdue MSE, we have folks that work on soft materials, like using biomass to make renewable ethanol. My group also works with surfactants that are used for the feedstocks to make shampoo. We also do some work involving polymer particles that are used in high-performance concrete. So even within my own research group, we have applications that range from agricultural engineering to chemical engineering to civil engineering in one group. It's super fun. So what do actual MSE students do when they leave Purdue? And so I've got this great video here from Sarah Port, who was a recent graduate from our program.
Hi, my name is Sarah, and I'm a materials engineer for Bridgestone Americas. Being in product and development, I work in between research and manufacturing. I work on both bringing in new technologies into mass production while also improving upon our current and existing products. Materials engineering for tires has 2 specific categories. We have our reinforcing materials and our rubber compounding materials. For reinforcements, we have different fabrics, nylon, polyester, rayon, things like that. And we have our steel components, which are plated in either brass or bronze to help adhere to our rubber components. The whole purpose of our reinforcement materials is to provide durability and dimensional stability for our tire. On the rubber compounding side, we have to bring together all these different raw materials or ingredients, mix them together into a homogeneous rubber sample, and test those physical properties for a specific design target. The base of every formulation is our rubber or our polymer. We have to work with either styrene butadiene, polybutadiene, or other synthetic rubbers that we make in a lab, or work on our natural rubbers, which come from the latex of specific trees. So depending on which application we're looking into, we have, for example, our passenger tire, which is a cross section here. You can see all the different layers and components. Each of these components is a different formulation or different compound. For a passenger tire, you can have up to 15 different formulations. And each formula has a specific purpose. So whether you're trying to improve your cornering, your fuel efficiency, your wet stopping distance, things like that, will change your formulation. So a typical product that I would normally get is if I were to be given either a new raw material or a new raw material source, I would have to develop the formulation for that. So I would work in our labs downstairs to design a formula on a small scale, so maybe 3 to 6 pounds of material, test those properties for modulus, tensile, cracking, ozone, different things like that. Once I have selected a specific formula, I would put it into manufacturing, again at a smaller scale. So I'm only mixing and manufacturing maybe 1 to 3 pounds, or 1 to 3,000 pounds, of material. And we would test that again to see if the manufacturing side of things can meet that design target that I saw on that small scale. Once we have done that and we have proven the actual feasibility of it, we actually build a tire. So once we build a tire, we have to test it either on a track or a drum to make sure that whatever tire performance or tire performance metric that we're looking into is either improved or stays the same so that the customer is happy or satisfied with whatever tire we put in the market. And so that's kind of the gist of what I do for materials engineering. It's a really cool job, and I work with a lot of different people from tire design groups, research groups, manufacturing, procurement, quality, just engineers from all around the world, really. But please consider materials engineering and boiler up.
All right. So that's Sarah. I remember her when she was an undergrad, actually, in our courses. And it's so cool to think that she's out there making tires, going from 15 different formulations all the way to a full-scale tire composite. Who knew tires were so cool? MSEs knew that. Materials engineering involves a lot of innovation, and a lot of the key innovations over time are materials driven. So for instance, bicycles look the same pretty much from the 1800s as they do today. So the biggest innovation is that we use new materials to enhance the performance of bicycles, going from steel frames back in the day to aluminum and high-strength composites that are lighter, more durable, and allow you to go faster and pedal longer. Transistors are another example of this. Back in the day, they were energy hogs, they were slow, they were massive. Nowadays, transistors are smaller, faster, and much cheaper, allowing us to have transistors in all of our pockets. And that's the primary control unit of a semiconductor. So anytime you have a computer, like your phone, you've got transistors in your pockets doing that work. Aircraft engines look about the same as they did in the 90s, that top image there, but nowadays they're much more efficient, especially at high temperatures where you can really burn your fuel as hot as you can to get all the power out of that engine. And the components last longer at these higher temperatures. Those are all innovations driven not by the specific design of the structures, but by the materials that were selected to build those components. And we improve lives. So for instance, with the recent pandemic, copper and its antimicrobial properties were all throughout the news. We're now doing things in our department where we 3D print concrete. So that's very much a civil engineering domain, but faculty on campus 3D print different concrete structures specifically for wind energy turbines at the base of those turbines. We use organic semiconductors for brain-inspired computing. MSCs focus on the nanomaterials that are used for electrochemical water splitting. And of course, we know all about material recycling, and that's becoming more and more important as we think about the carbon footprint and the water footprint and the sustainability of the materials that we make and use every day. So here's some facts about Purdue MSE. So in terms of our undergraduate demographics, we're about 30% female. We're about 10% underrepresented groups in STEM. We're ranked 11th in last year's U.S. News and World Report. So we're right on par with Penn State University and Carnegie Mellon. Both very good, but Purdue is way better, of course. We have a wonderful graduating student to faculty ratio, so 2 to 1. So we're a small school on a big campus. And if you want to get to know your professors and actually have a relationship with them, come to Purdue MSE because all of our faculty get to know our students. We have expanding co-op and study abroad options within our department. We also are getting into more entrepreneurship and business plan competitions within Purdue. And as I mentioned before, all types of materials are represented. We're not just your grandpa's steel department anymore. We actually do all sorts of material science within our school. And we're located in Arms, which is a great building. So our undergraduate students come from all over the place. So about 35% come from Indiana, 55% come from out of state, with Illinois and California being the largest states where our students come from. And about 10% of our students are international from 12 different countries around the world. In terms of numbers, so at Purdue, we graduate about 50 to 80 MSCs every year. And what that means is about 3 to 4% of all materials engineers in the US come from Purdue, because nationally there's only about 2,000 MSCs that graduate every year. So we're a small school on campus, but we're a big school in materials engineering. Typically, we're ranked in the top 5 largest MSc programs in the country. So don't think we're small, we're actually a very big deal. And so here's a bit more about the different types of experiences you can have in materials engineering. So first, we like to make stuff. We like it a lot. We have all these hands-on processing approaches that we do in our labs, and we have a very lab-intensive curriculum. Our sophomores have a lab course, our juniors have a lab course, and our senior design is a 2-semester lab experience. A lot of our students are very busy making stuff over the summer as well. So they do the co-op program, they do industrial internships, and a lot of them also do research experiences. And it's important to note that 75% of our students have an industry experience before they even get to their senior year. And these are some images of undergrads in our lab courses, the sophomore and junior labs, making stuff, and also doing some computer simulations of defects within various materials. In terms of other experiential learning, over 50% of our undergrads participate in research. This is a big deal. We have the largest number of students across the whole College of Engineering who do research in MSc, and we're a small school, so think about that. If you want to get involved in research, come to MSc because we do tons of it. You can do research for credit. You can earn up to 6 credits that actually count towards graduation, and you can even do research over the summer and get paid. These are all pictures of actually undergraduate researchers who came through my own research group, and they're all doing awesome things in the world now. There's numerous study abroad opportunities available for MSCs. If research isn't your thing, you can go somewhere else in the world and take classes and have industrial internships. And it's noteworthy that 2 of the recent Purdue Goldwater Fellows have been MSCs. And the Goldwater Fellowship allows students to go off and do prestigious research internships around the world. Here are some examples of the senior design that takes place the final year. So our senior design program is 100% funded by industry. It's a 2-semester experience, so fall and spring. Our student teams are partnered with these different companies, and the teams have a real impact. Our industry sponsors give us a real problem that they might not have the time to solve themselves, and our student teams figure it out. And so these are all examples of some of the metal company, the polymer companies, and the ceramics companies that partner with our students. So a little bit about the Purdue MSE curriculum. So within the sophomore year, there's 5 required MSE courses, there's a lab course, there's a couple lectures. All of our sophomore courses are taught both in the fall and the spring, so you can mix and match and customize your schedule to meet your needs. In the junior year, there's typically 7 MSE courses. There are 2 labs and 5 lectures. And again, you can mix and match as you need to. We've tried to make the curriculum very flexible because we understand that you might want to take a course in a different major. You want to pursue a minor. You might want to take some more gen eds. It's fun to be at college, and we don't want the MSE curriculum to constrain your goals for your full college experience. In our senior year, we have a smaller number of required courses. There's senior design and there's 1 lecture on material selection. But by then, you're also taking a bunch of 500 level tech electives, which are all your choice. And the tech electives range from polymer processing to semiconductors to coatings and electronic materials. So you can really customize your major to fit exactly what your goals are. And you can also try out different sides of the field. You can take a course in polymers, you can take a course in metals, you can see what you like. So, which means that there is no normal MSE graduate. At graduation, the majority of our students go off and work in industry in all sectors, manufacturing, aeronautics, automotive, sustainability, health, pharma, personal care, all over the place. About 25% of our students go on to graduate school, and most of the time they have a full paid experience. And about 5% are still looking. A lot of them have often turned down an opportunity to maybe take a gap year, do something different, travel the world. Very cool. And there's all sorts of interesting graduating student data available on the CCO website. So with that, I'm going to turn it over to my MSE students who are going to give you some real-time feedback and their perspectives on our major.
Hello everyone, my name is Zach Logar. I'm a senior in materials engineering from Glen Gardner, New Jersey, and I also have a minor in global engineering studies here at Purdue through the GEAR program. The GEAR program is the Global Engineering Alliance for Research and Education through the Office of Professional Practice. It's an international experiential learning opportunity where I was able to take part in an international study abroad and work abroad opportunity, so that integrates on top of the curriculum in materials engineering. I also, in extracurriculars, I'm a part of PUMA, which is Purdue University Material Advantage. That's just our professional and social organization for materials engineers. I've had opportunities to attend various industrial opportunities such as conferences, but also have social events here on campus with other students, learning more students from the department. My job experiences, I was a material and process engineer with Northrop Grumman, so that really emphasized the multidisciplinary team aspect that Professor Erk mentioned. Material and process sat independent, but worked across all different engineering disciplines at Northrop Grumman. So in my role, I was working with design engineers from the aero department, the electronics department, the industrial department to design and approve new materials for use and design considerations. So I was writing test plans, evaluating procurement of materials, ensuring that the materials were going to meet the lifetime of the program and that they would meet the supposed expectation for its use case. This summer, after I graduate, I'll be going to 3M to do a little bit of a different role doing polymer research and development as a graduate intern. So I'll be working in their industrial adhesives and tapes division, slightly different in their electronics bonding group. So investigating more on the consumer side of products, how new materials can interface outside of an aerospace application. I have taken part in undergraduate research here at the department. So this was kind of a unique project. This was an industrial sponsorship with Helmet Aerospace for a design competition run through ASM, which is an international materials organization. I specifically looked with 7050 aluminum, which is an aerospace grade aluminum, and Helmet Aerospace was having a processing problem that they wanted us to investigate. So we started from bulk material all the way to designing samples to test where we wanted to look at, which was a great addition into the class learnings that we had. And figuring out how we can better optimize the process for our industrial sponsor. One of my favorite classes that I've taken here at Purdue has been Transport Phenomena, which is MSE 340. It's a junior level course. In short, it's heat and mass transport. And it really helped tie together a lot of our classwork that you do in your sophomore year and especially in your junior year. It also made math make sense in an engineering concept. And Dr. Crane really gave a lot of interesting perspectives on different ways to solve engineering problems. Toughest class, I'll say, is definitely senior design. It's the most enjoyable and most rewarding class, but that's not to say it can't be tough. I'm on a senior design project sponsored by John Deere and Inducto Heat, so I've been working with them over the past 6 months, and it's tough in terms of you're essentially working for the company. So on top of all my other schoolwork, I'm having regular meetings with them, status updates, presentations. Really gives you the run through of what it feels like to be an engineer once you're going to leave graduation. Post-graduation, I'm recently a part of the new 4+1 program at Purdue, so I'll be staying around for an extra year to complete my master's degree in materials engineering. So that's where it allows me to go to 3M this summer in between graduate and undergraduate programs. And I think skills to be successful are definitely team and project management. Those are stressed in the lab classes, working amongst other students, but then also in senior design, working with other companies and other individuals outside of industry and academics as well.
Hi, my name is Megh Kansara. I'm from San Jose, California. I'm a senior in MSE this year, and let me tell you a little bit about my extracurriculars and my involvements at Purdue. I'm part of PUMA, the president of the club this year, and we try to cater towards students in materials engineering, giving them opportunities for professional development, visiting professional conferences, and meeting industry professionals, as well as materials competitions. One notable one that we do that happens twice every 2 years. It is the blacksmithing competition, in which we use metallurgy and the art aspect of metalsmithing and curate a sword and present this at the competition itself. So this year, students will be attending TMS, which is a conference for the Metals, Minerals, and Materials Society, and this will be taking place in Orlando, Florida, which we will showcase this blade. Another one of my involvements is the Women in Engineering program, which I serve as an upperclassman mentor, meeting students who are just starting out in engineering and helping them pursue their passions and finding that discipline for them. Another thing I take part in is working in the university residences. In the past, I worked as an RA for the Women in Engineering learning communities, again, just helping freshman year engineers find their passion and show them all the opportunities available at Purdue. Currently, I also work just at the front desk, just greeting people that are entering the residence halls and just showcasing hospitality. Some of my job experiences this summer, I worked at Logan Aluminum, which is based in Russellville, Kentucky. They create metal aluminum sheet, which is used for beverage cans. That was my specific project. So all the cans that we have for soda, beer, or just energy drinks, that just comes from this aluminum sheet. So there are specific standards that we're trying to meet, and just looking at the quality and processing as well. Some research that I participated here at Purdue was the ASM Design Challenge. This was with my friend who just talked earlier, Zach Logar. So this was for Howmet Aerospace. And I would say one of my favorite classes, an interesting one that I took at Purdue through MSE, was Sports Engineering and Entrepreneurship. This showed me a different aspect of engineering, and especially the business side of it, and how it can present an engineering idea to people, to investors, or just putting it out there for the general public. One of the toughest classes, I would also agree with Zach, would be senior design. This was my first time tackling an industry project with an end goal that is kind of up to me and my team. Our project is, currently it is with Logan Aluminum. This is working on edge delamination for cold rolled metal sheet. So one hard aspect of this is also being a team leader and making sure that we are utilizing time management and prioritizing our tasks and trying to come up with a solution that is not already present. So post-graduation, some of my goals are to become metallurgical engineering, more on the R&D side, and work towards process and product development. And I would say throughout my career here at Purdue and MSE, some skills to be successful is definitely working on your time management and prioritizing your tasks and understanding which one do we want to put first on our list.
Hello, my name is Donovan Stumpf. I'm a senior in MSE from Carmel, Indiana. And I am also pursuing a minor in Spanish for the Professions, which is a minor dedicated to learning Spanish for applications in industry. So I'm part of a number of different extracurricular clubs, including PUMA, AFS, which is the metal casting club here on campus, which we can make items to be able to keep out of aluminum, bismuth. I know that they were talking about trying to incorporate some cast iron as well. And then I'm also part of the American Chemical Society Student Affiliate, which is a club. It's a chapter of American Chemical Society here at Purdue that works on trying to network and have social events related to chemistry and some of the applications of chemistry. So job experience this summer, I'm going to be having an internship between my 4+1, which I'll be doing next year post-graduation, and my undergraduate degree. So I've been taking part in a couple different research projects, including the bilge water emulsions, which is the water at the bottom of a ship, and how the droplets of oil can form to very such small size. And then I'm also doing image analysis of particles with Dr. Mort, and we are looking at how we might be able to utilize different machines and machine learning algorithms to better understand how we can, the shape and size effects of powders. So my favorite class was powder processing with Dr. Mort. After that class, I ended up getting involved in research with him. And my toughest class that I've had so far was 340, Transport Phenomena. It was a hard class, but it taught us a lot of skills that was necessary for us to understand the applications of math that we took and many other important aspects of fluid flow and mass, heat and mass. And post-graduation, as I said earlier, I'm going to attend a 4+1 degree. And I'd say the skills to be successful include time management and team management, which are both very important to be able to work with a group and manage your schedule and everyone else's.
So one of the most frequently asked questions we get asked is, what is the difference between MSE and other engineering disciplines? I would say generally MSE relates to how materials react to different forces and stimuli. So this is a big difference compared to chemical engineering. And typically we are catered more towards research and laboratory testing.
So another question we get kind of in line with that is, are there many opportunities for hands-on experience and internship, co-op opportunities? And we mentioned a lot of those opportunities that are available. So undergraduate research, over 50% of our department does it. And it's available for first-year students as well. If there's opportunities that fit for the professor's needs and you're interested in the project, feel free to reach out. Our MSE department page, almost all the professors' pages have research projects that they're actively working on that are available for students to join. And then internship experiences as well. You kind of heard the variety that all three of us had, but there's plenty of opportunities. I like to say MSEs can wear many different hats, and that's just subject to how many different roles that we could take on and how we fit into an organization as well.
And another commonly asked question is sort of how might we be able to fit a minor into our plan of study? So a minor is used to supplement your education, whether it be a foreign language or something you're just interested in. So you can fit it in by taking it as support area electives, general education electives, and it will fill in some of those spots to minimize the number of extra classes you'll have to take.
Thank you for watching this video. We hope you've learned a lot about MSE, what it is, what it isn't, and if you have additional questions, please contact our undergraduate advisor. And good luck in the future. Boiler up!